Look at this flow chart. It is an implementation of back-off algorithm. So before watching this video, I assume that you have already watched the videos of back-off algorithm. It is an extension to that. I already explained you the algorithm, and whatever this flow chart is, it is in one of the LANs. They are implementing the algorithm using this flow chart. So many of the numbers which are present in this are LAN dependent, which means for every LAN it is not going to be same. I am just taking a case study. In one of the LANs it is what has implemented, and let's see how it is implemented. And it does not mean that every LAN should follow the same standards. They might have their own standards, right? So but still it is worth looking at it, so that it will give you more insight about how the back-off algorithm is implemented. And remember that the numbers which I used here, they vary from LAN to LAN. Okay, they depends on what is the bandwidth and what is the length of the LAN and what is the propagation delay, various factors. But anyway, I am assuming that it is only for one particular LAN. Okay, keep that in mind. Now see this. If a station wants to send the frame, first command is send frame is given to a station. Then what it will do is it will take the frame and it will set n equal to 0. Do you remember? N is nothing but the collision number. I told you when I was discussing about the back-off algorithm, n is nothing but the collision number, which means initially the collision number for the frame is 0. Initially n equal to 0. Now that frame will be given. Now when the frame has to be transmitted, first we test whether the carrier is busy or not, which means that is called carrier sensing. The reason is we are following CSMS CD. CS means sense the carrier. Before you put anything onto the channel, you just see if the channel is idle like this or if the channel is busy, which means already some signal is going on. If it is busy, which means some signal is going on, defer means don't send the packet now, just wait for some time. After waiting for some time, again sense it. Then if it is again busy, then wait. If it is idle means if it is not busy, if you have seen that there is no packet on the data, then wait for 96.9.6 microseconds. Again, it is also implementation dependent. The reason is whenever you send one frame and when you send the next frame, you are supposed to give at least some delay. Even though the link is idle, you are supposed to give some delay, so that in the meantime, if someone wants to send a packet, they could send a packet. Otherwise, if you don't give any gap like this, what happens is you will be sending first frame and then second frame, third frame, fourth frame, like that you will keep on sending 1000 frames, and for the entire duration all the other stations will continuously be seeing the signal, and they will get what can I say, they will get starvation, isn't it? Or it is also called as monopolization. Therefore, see, do you remember already we have a limitation on the maximum frame size. We are having a limitation on maximum frame size in order to avoid the monopolization, which means if you have 1 GB of data, you are not supposed to send it. You are supposed to send only 1500 bytes. But then if you divide it into many frames, and if you are combining all the frames together and sending them immediately one after the other, there is no use of doing this breaking the data into many frames. Therefore, after sending every frame, you are supposed to wait for some time, and it is actually implementation dependent. Either it is 9.6 microseconds, or some LANs might keep it 0, which means you need not wait at all. Therefore, if there is no interframe delay, you need not have this step. So what is this step? In case if you want to give some delay after every frame, even though the LAN is idle, you are supposed to wait for 9.6 microseconds, then only you are supposed to send your frame, right? And in this meantime, after sensing it and this 9.6 microseconds, if there is a signal, obviously there will be a collision, which means someone else also wants to send the data, you also wants to send the data, and then again this algorithm will play. But anyway, just remember that it is just for the interframe delay, and after that transmit the frame, which means just keep transmitting. Then while transmitting, there could be a collision. We are following CSMS CD, which means you are supposed to detect the collision in case if there is any collision. Therefore, if there is a collision, yes. In case if there is a collision, then we shall see what to do. If there is no collision, then it is done, then nothing. You have started the transmission, waited, and then you transmitted, and it is done, fine, it is good. If there is a collision, which means you are sending the data and a collision signal came back to you. Somewhere your data got collided and the collision signal came back to you, right? Then every station on the way who detects the collision should always transmit something called as jamming signal. So there is a 48-bit signal which is called as jamming signal. So the rule is like this: whenever any station observes a collision signal, it should inform everyone else that there is a collision. Therefore, you please abort whatever packets you have received till now. Why this jamming signal is implemented is, let us assume that there is a station A and the station is sending the message to station B, but since it is bus architecture, the data signal will go in both the directions, right? So A wants to send a message to B, at the same time D is, the message is going in both the directions and B is reading, and suddenly there is a collision at B, and therefore the collision signal came back, and who will listen to this collision signal first? A. Therefore A will immediately stop transmitting its data, completely stop it. Then what happens is, abruptly B will see that A has sent only part of the data and it stopped. Therefore you should even inform B and everyone else in the channel, whoever is listening to the data, that there is a collision, therefore I stopped it. So it is the responsibility of every station in the network, or at least the one who received it, to issue a jamming signal. Jamming signal is nothing but a special signal which goes in a different frequency, which will say everyone that there is a collision, therefore you please abort reading whatever you read. So if B hears this jamming signal, then it will stop reading the packet. The reason is, half of the packet is sent and after that half of the packet is lost in collision. Therefore the sender has aborted the transmission. Therefore the sender should even inform everyone that I aborted the transmission, so you please discard the packets which you have learned, which you have accepted partially. For that reason there is a jamming signal which will be sent. Therefore transmit 48-bit jamming signal, which is nothing but we are going to transmit a special packet which is jamming signal. And some other properties about jamming signal is, even though the line is having collision signal, when you send the jamming signal is not going to collide with the collision signal. The reason is, jamming signal will be sent at a different frequency. Only for jamming signal, one different frequency is reserved in Ethernet, and for the other data signals, the other frequency is reserved. Therefore we have two frequencies. Jamming signal will go in a different frequency without colliding with anyone. Therefore in case if B receives the jamming signal, it will discard half of the packet which is received. So it is generally a rule that whenever there is a collision and anyone who listens to the collision signal, they should send the jamming signal. And remember that jamming signal is not going to affect the minimum packet size. In one of the gate questions they computed it wrong, which means they said that this is so and so is the jamming signal, therefore what is the minimum packet size? Minimum packet size does not depend on jamming signal. And the minimum packet size is always L is greater than or equal to 2 into TP into bandwidth. So coming to this jamming signal, I'll take one more question. In that I'll explain you the jamming signal very clearly, but for now just keep it simple. Assume that any station who detects a collision is supposed to send a jamming signal, which is generally a 48-bit. And now after the detecting the collision, what happens to the collision number? So as of now the collision number has to be increased. You remember that for every frame, whenever there is a collision, the collision number has to be increased. Therefore the range of numbers it will generate for the next time is going to be increased. Therefore collision number has to be increased. Now after increasing the collision number, we have a testing condition here. So I think that you remember about the flow chart, the conventions. Even if you don't remember it, keep following the algorithm. This diamond is generally for a test, which means if condition like that. So here the test is n less than 15. So in this implementation what they are trying to do is, if a station got involved in collision, if a frame got involved in collision continuously, I told you that at the algorithm the rule is after reaching 10, which means if n equal to 10 maximum number, then you abort it, don't go for further. But this implementation is going even further till 15, that is implementation dependent. You could set it to 100 also, no problem, but then it is useless. So they are saying that if n equal to 15, which means if this is the 15th time you are actually colliding, then you abort. Abort means it is okay, you have tried enough, just stop it for now. And if it is less than 15, and now again one more test, which means they are testing if it is less than 15, is it less than 10? In case if it is less than or equal to 10, then r is set to n. So what they really mean is, by this entire test case, what they really mean to do is, they are starting the n is the number which is used to indicate the collision from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and from here they are going to 11, 12, 13, 14, 15, till 15 n is running. But then whenever n is less than or equal to 10, r equal to n, which means they are using one more number r which is set to n till this point, which means till n is from 0 to 10, r is going to be from 0 to 10. So what they are trying to do is, they are using one more variable for which they are setting r equal to 0 to 10. So r equal to n till 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the meaning of it. If n is less than or equal to 10, then you just set r equal to n. That is it. If n is greater than 10, which means if n crosses this 10, then you set r equal to 10. Which means from here on, if n is greater than 10, then you set r equal to 10, 10, 10, 10, 10. So what does this mean? Whatever your collision number is from 0 to 15, you are going to set a variable r from 0 to 10 only, right? Even though the collision number is greater than 10, you are never going to have r. Why is this r used? I'll tell you. You are never going to cross this r more than 10. Now after setting this r, then we are selecting a random number from 0 to 2 power r minus 1. 2 power r minus 1. What does that mean? You are always going to use the random number from 0 to 10 only. So even though the collision number is 15, you will treat the collision number to be 10 for some time. It is somewhat difficult to understand. Just try to understand it. See, collision number is going to be from 0 to 10. We are actually supposed to stop at 10 according to the algorithm. But what this implementation is trying to do is, it is giving it some more grace time, which means even after reaching 10, you can go beyond 10. Beyond 10 means like this. Even after reaching 10, if you can, they are giving some more time, 11, 12, 13, 14, 15. For all these tries, they are expecting that, or they want to set the collision number to be 10. Therefore, we are getting actually 5 more chances. Actually, you are supposed to stop this entire algorithm whenever it reaches 10, but then we are going for 5 more times, and for every more attempt you do, you always expect that the collision number is still 10. So it is simple. R or n both are same. Only difference is we are giving some more extra time or a grace time for a frame. If it has already reached 10 collisions, after that it can try for 5 more collisions. Even though it is losing every collision, we still consider as if it is the 10th collision, right? So if it is confusing, you can assume that this loop is not there, and you can simply say k equal to 0 to 2 power n minus 1, and you can stop it at 10. That is also a simple implementation, but anyways their implementation is doing this, right? Then we are going to select a random number from 0 to 2 power r minus 1. It is same. It is how I did it in the algorithm. So once we have this collision number, we are going to choose a number from 0 to 2 power collision number minus 1. Remember it? Okay. Now after that, once we choose that number k, then we are going to multiply there with k into some waiting time. So here 51.2 is nothing but that slot time. I told you that waiting time equal to k into some slot time, and again this slot time depends on the implementation, which means how much time you are going to give for one slot. That varies from LAN to LAN depending on how long the LAN is and what is the bandwidth. After that, again you can go and try and transmit the packet. How to transmit the packet? Just sense the carrier. If it is busy, you wait. If it is idle, you transmit it. Everything is going to happen the same way, right? What if this arrow is pointing here? Can I directly write this arrow here? Instead of putting it here, if I put it here, what happens is, every time after collision, the collision number has to be increased, but then if you put it here, the collision number will again become 0. So every packet, even if after 100 collisions, it will still be getting 0. So initially it will get n equal to 0, then it will come across this path with n equal to 1. Again you are going to make n equal to 0. Again it will come at n equal to 1. So it will keep on happening. Therefore, you should be very careful when you are giving this edge. This edge should be given not here, it should be given here. Got it? So this is one implementation, and the numbers and the procedure used is actually implementation dependent. It is not true that it should be followed in every Ethernet. They follow their own implementations, but then the algorithm is same. Find out the collision number and choose a random number and wait for random number into some T slot, right? Here the T slot is 51.2 microseconds. We shall discuss more about the jamming signal in some other problem. So once you finish watching all the problems, your doubts about the jamming signals are supposed to be clarified. Okay, fine.